everybody. So, change of topic. I want to talk about microservices testing. And I always feel a little bit of imposter syndrome when I talk about testing, because I'm a software developer. I am not a professional tester. I'm not a test specialist. In our community, there's some really fantastic speakers who are professional testers, and so I always think, oh, what am I doing talking about testing, when you could be going to see, Mara or someone like that. But then I give myself a talking to, because actually, all of us are testers, or at the very least, all of us should be testers. Testing is something that as a professional software engineer, we should be doing. And not only that, it's something that we should actually be happy about doing. I think, sometimes we sort of think, oh, testing, it's so boring. And in the conversation about ChatGPT, for example, often, it's like, we're going to automate the really boring and terrible parts of our job. We're going to automate the tests away. And it's like, well, I'm not sure that's necessarily where I would start with the automation. Because, testing can be really tedious. But if you do it right, it can be really interesting and challenging and fun to try and figure out how to write tests that are actually going to be great tests. And I think this comes back a bit to sort of a conversation about, well, what does testing mean? Now, how many of you were in Peter's talk just before this one? Okay, probably about half of you, I think. So for those of you who are in Peter's talk, I apologize, because we were talking at dinner last night, and so I have stolen some of his content, because we were talking, and I thought, yeah, that's really good, I'll add it to my slides. And then I watched his talk, and then I realized, oh no, I've just stolen part of your talk. But I think this is actually worth repeating, because it's really important to think about, well, why are we doing this? What do we really mean when we talk about testing? And I think the mechanical definition is testing is writing tests. As long as I, write lots of things with @test, and especially if I write lots of things with @test, then I'm doing a good job, testing my code. And I'm like, well, I'm not really sure. It's not a case of quantity over quality with tests. But I think we can get a bit consumed by metrics. So, often we can get so excited by test coverage, and I think SonarQube perhaps has some blame here, that we forget about why we're writing the test. And we're like, I'm writing tests to get to 95% test coverage. No, I'm better than you. I got to 98% test coverage. No. Well, I got to 100% test coverage, and it only took me 2 weeks that I could have been doing something more useful with my time. Really? Was that helpful? And I was always a bit suspicious about code coverage, but I became very suspicious about code coverage when I had a sad project. And I was sort of, a consultant, and they brought me in because the project was troubled, and so I, went and looked at the code base, and the first thing I did, of course, was look at the tests. And they were doing, I'm very sad to say, because I'm a big fan of TDD, and I'm a big fan of pair programming. And I used to think that TDD and pair programming would solve all problems, because I was naive and young. And then I looked at this code that had been written using beautiful, pure test-driven development and pair programming. And there was every single method had a test written for it first. And there was not a single assertion, not even one assertion in all of these tests. So as far as I could tell, the only way that you could possibly have made these tests fail was if some of your code threw a null pointer exception or failed to compile or something like that. And they were really proud of themselves, the developers who'd written this, and I thought, oh, okay, we have to have a conversation. Because the point of tests isn't the writing of tests. The point of tests isn't the coverage. The point of tests is to give you confidence that the thing you're writing works. And there's another part of this, too, which is the point of tests is to give you confidence to make changes, because any business application has to be able to change, and that's often the hardest thing. And I saw Martin Fowler once, and he said that the tests are the skeleton that allows your code to move. And so if you have those tests, then that means that you can make changes and add features and do all the exciting stuff that's kind of quite exciting and that your users want. And so where do microservices come in? Well, a lot of organizations have been moving to microservices over the last 5 years. And when you ask, so why are you doing microservices? Sometimes actually that already kind of kills the conversation. And they kind of go, we hadn't really thought about why we're doing microservices. Everybody else is doing microservices, so we thought we should too. And then, sometimes if you dig a bit more, you get Netflix. Okay, yeah, but why are you doing microservices? Still Netflix? But then, sometimes if you dig a bit more, then oftentimes the motivator for microservices is to be able to change things more easily. We can't change our application, it takes us so long to deploy, we want to do microservices. So that's great, right? Because the goal of testing is to allow you to change. The goal of microservices is to allow you to change. So we're all going in the same direction. These two things should be really well aligned. Well, sort of. Definitely, the sort of the theory and the practice don't always line up. So I think what a lot of organizations found is that they started to move to microservices, and they thought they were testing okay, and then they realized that no, they had a whole bunch more to learn. Because if you're doing microservices, you need to get really, really good at the testing, and you need to get really good at the automation. But I think sometimes it takes a while to realize that. I saw a very amusing blog post from Matt Stratton once, and he said, if your microservice only does one thing, it can't have an error. That would be an additional thing. He wasn't being serious, of course, but I think actually a lot of us do end up believing something sort of similar, and there's a whole bunch of fallacies around microservices. And fallacies, I think, really what we mean here is things that we wish were true, that, we desperately want them to be true. They're not always true. And so when we move to microservices, I think we imagine that our job testing things is going to get so much easier. Because instead of having a big monolith to test, we're responsible for one tiny little service, and we only need to test that tiny little service. Unfortunately, that tiny little service is part of a big system. And if you think, that's the Netflix microservice architecture, and if you only imagine testing the points and not the lines, you're missing almost all of the complexity of the system. And complexity is annoying, but complexity is also where the bugs are, which means you're missing testing the vast majority of the system. And I think with microservices, because it allows us to take responsibility for one service, which is really good in a lot of ways, but I think it can then lead to a bit of a tribal problem as well, where you say, well, I've tested my service. I've got unit tests. I've got coverage. I even have assertions in my unit tests. If the whole system doesn't work, that's clearly not my fault. That would be the fault of those other people using my service, or those other people whose service I'm using, because my service has tests. Well, no. We have to think about the whole system. No. I don't have to think about the whole system. You see, we're using microservices, so we're decoupled. Well, no. There is still a lot of coupling in that architecture diagram. You can't just sort of go, poof, the lines have disappeared. And I think with microservices, there's this really strong temptation, because distributed and decoupled both start with D. We kind of imagine that if I smear my communication across the network, it means I'm decoupled. Well, no, it just means that you're distributed, and testing's a lot harder, and debugging's a lot harder. And we definitely do see a lot of communication problems between microservices, and they usually only show up when you do some kind of integration testing. And, there's sort of classic things. So like on the very troubled project, basically every time anybody touched anything, the whole system broke. And one of the classics was, what do you mean you corrected the typo in your JSON? That broke everything. And then, of course, there's misunderstandings about behavior. We weren't expecting your service to do that. Nobody told us it did that. We even read the docs. And I'm stealing something else from Peter again. He told me a story yesterday that something was calling an API, and they'd managed to put the value into the wrong field in the API, which seems like something that shouldn't happen. But of course, in this case, there was about 15 fields in the API. Some of the names weren't very clear. That's exactly the kind of thing that's going to happen. And OpenAPI and just reading OpenAPI isn't going to fix that. You need something that tests. And when we talk about decoupled, just because a system can't ever be perfectly decoupled doesn't mean it's not a good goal. Kent Beck talks about managing coupling rather than being decoupled. So the idea is, I really want to know where my points of coupling are. I have to have some because this is a system, but I want to understand them. And Dave Farley has a really good heuristic for understanding how much coupling there is in a system, which is when he goes into a new project as a consultant, he looks at the versions on all of the modules or all of the microservices. Because if you're decoupled, if you're truly decoupled, you can deploy things independently. If every single service has the same version, you are clearly not deploying these things independently. So this is a highly coupled system, or there's a fear that it's a highly coupled system. And something much healthier in terms of coupling is something like this. I mentioned TDD. I'm a big fan of TDD. A sort of an obvious reason to do TDD is I think it really does improve the quality. But there's other reasons to do TDD. And so when people talk about how ChatGPT will make the need for TDD go away, it makes me sad because TDD, it's not just about generating the test code. It's a really good design tool. It helps you think really clearly about what do I want, how do I know what success looks like, and what problem am I actually trying to solve. And often what we find when we do TDD is some things are really hard to test. And that's a smell that tells us, okay, actually, if this is hard to test, I think that shows that there's a problem in my design. And so it drives the code just by the act of doing TDD. But having said all of that, the real reason to do TDD is that it is gamified testing. So the thrill you feel when you've got that red thing and you make it go green, it's kind of exciting. So how many of you know the test pyramid? I think probably, yeah, most of you. When I talk about TDD, I think sometimes people think about TDD as like only for unit testing, which is just so wrong. TDD is something that you can and should be doing at every level of the test pyramid. So at the top of your test pyramid, you have the end-to-end tests. Those are wonderful because they give you a lot of confidence, but unfortunately they're really expensive and annoying to write. At the middle layer, you have the integration tests. And then at the bottom, you have the unit tests. The unit tests are great because the effort to write them is so low, but the only problem is they're the ones most likely to actually not catch bugs. Whereas the end-to-end tests, they're super realistic, so they're really good, they're high value, but they're expensive and annoying, and you definitely shouldn't write too many of them. Now, there's been a lot of debate about the test pyramid. I still find it useful as a mental framework, but particularly that middle layer, integration tests, it doesn't mean anything like the same thing as it did 10 or 15 years ago, because it used to be that a test with an application server was definitely like quite an expensive integration test, whereas now it's really a unit test almost. And if you're testing a REST endpoint, that's definitely something that you can do in your unit tests, which didn't used to be the case. So let's talk about the unit tests first. Those are definitely going to be something that you're going to want a reasonable number of. But there is a problem with unit tests, and again, this is something that Peter talked about earlier, which is that we say unit tests are cheap to write, but actually, if you have to do a lot of mocking in your unit test, all of a sudden it is not cheap to write. It is actually expensive to write because you're spending all this time writing mocks. And to add insult to injury, you spent half a day or a day like writing a whole mock version of this thing that you depend on. And then your test still doesn't actually catch the problems. So what's even the point? And the reason that unit tests aren't enough really again has to come back down again to some of this communication. So if we have two systems, and we have a conversation and we say, yep, our API looks like that. Great, I will code to that API. And so, well, technically that would be a stub, not a mock, but I always say mock because it's easiest. Any case, so we write a mock that looks like what we were told the system works like. And our tests pass. Awesome. Sadly, they didn't actually implement what they said they were going to implement. They implemented something that had a slightly different interface, which means even though our tests are passing, reality is broken. And so then this is where, in order to catch that kind of problem, you've got to have an integration test. And actually, there's so many things that you do that need what would technically be an integration test. Because any time you serialize or deserialize data, that's got to be an integration test. And basically anything you might do involves serializing or deserializing data. So if you're going to be calling to a database, if you're going to have a REST endpoint, that counts. If you're doing any kind of queuing, any kind of ETL, that counts. Anything to the file system technically would be that. And then, of course, the big one is if you're calling out to other services, whether they're your colleague services that you have some control over or external applications that you have no control over. In all of these cases, there's data coming in and out of your application, and so you do need those integration tests. Because otherwise, most of the data coming in and out might be fine, but there's just one or two that are going to go quite badly for you. And so because of that, the fact that integration test means anything involving data or an external system, some people actually reframe the test pyramid model, and they say, instead of having a test pyramid, let's spend more of our time on the integration tests, because they're not as annoying as end-to-end tests, but they're not as useless as unit tests. And let's shrink how much time we spend on unit tests. And so then what you end up with, instead of a pyramid, you sort of end up with like a blobble shape like that. And so then they call it the test trophy, which also makes it sound like you're winning at testing. So let's talk about those end-to-end tests. Usually when we do end-to-end tests, because we are not a maniac, we do them in staging. But this creates its own problem, which is we design staging to be as much like production as possible. But there's just one or two little things, like the load is about 1% of what we get in production. And of course, all of the data can't be real customer data, so it's made up data, which is different from the customer data, and we don't have that customer with a really weird name. And so what with one thing and another, all of the compromises that we make for staging, staging doesn't end up necessarily being particularly useful. And there's a whole category of problems that only happen in production, even though you were confident in staging. And it's because we have a model of what production looks like, and we try and replicate that in staging. But it's just like the mocks. Our model doesn't necessarily match the messy reality. And so I think, as well as you have to probably, in most cases, have staging, but you definitely can't rely too much on staging. And so instead, you probably want to also be thinking about testing in production. And now when you say testing in production, there's a group of people that will go, oh, because it sounds really, really sort of reckless and like, I can't be bothered to test anywhere. I'll just like try it out and then we'll see what happens. But the thing about testing in production is that if you don't test in production, your customers will be testing in production. And so when we say testing in production, I don't think we necessarily mean, well, in fact, we definitely don't mean don't test anywhere else. We just mean that you want to be able to collect data from production and validate in production quickly. And if problems happen in production, you need to be able to diagnose those problems. So sort of proper testing in production doesn't mean abandoning testing everywhere else, but it means that you need to have really good observability. And maybe you can do canary deploys and then have the observability to let you know that it's safe to do a wider rollout. And you also have to be able to change things. So if you push something out to production and you test in production, and you discover there's a problem, and 4 days later, after you've gone through all of the release checklists, you get the new version out, that's no good. You have to be able to get things out quickly, but also safely. So when we think about the test trophy again, or the test pyramid, I think testing in production is that kind of little peak at the top that you definitely do want to be doing, but maybe not in huge quantities, and certainly not without removing everything else. So if you the pyramid, I think, has this really simple relationship of effort and confidence. At the top, it's high effort, high confidence. But I think it's actually a lot more complicated than that. So at one end, we have sort of these cheap and cheerful tests, and at the other end, we have these tests that are hard work and valuable. And then, of course, if we can figure out the tests that are cheap and valuable, that is totally winning. And there's some tests that are really expensive to write and really useless. We definitely shouldn't be doing those. So unit tests, I think, as long as we don't have too much mocking, are in the cheap and cheerful category. Integration tests are sort of somewhere in the middle. Those end-to-end tests are up at the top. Testing in production, it has two really good things about it. One is that it is so cheap. As long as you have, all of your observability, which you should have anyway, and your rapid pipelines, which you should have anyway, it's basically free, and it definitely tells you as much as possible whether things are working. And again, I think integration tests, we used to think of them as quite expensive. I think they're actually, well, sometimes very expensive, but often less expensive. And again, unit tests, we sometimes think of them as cheap, but if you have to spend a lot of time mocking, they are not. I also left out static tests. Static tests catch a good category of problems, and they are so cheap, so you should definitely do them. And one of the other things is I think we have to not be dogmatic about it. We have to sort of keep checking and going, well, these tests, they caught a lot of problems when I first wrote them, but now they're just expensive and annoying, so let's get rid of them. So let's talk more about integration tests, because integration tests is a really broad category, and they're definitely not all created equal. So there's some which are really cheap and really valuable, and there's others which aren't. And again, sometimes when we talk about integration tests, we mean just two things. Sometimes we mean actually lots of things together. And another category that's sort of close to integration tests but not quite is contract tests. So how do we approach our integration tests? One approach is to mock all the things outside the system under test. That is really annoying. It's the same problem as with the unit tests. Another thing that we can do is we can containerize all the things. That, in principle, makes it easier to spin up our dependencies. But there is still a cost to that. And colleagues of mine in the Red Hat Consulting, they got an email a while ago because someone wanted help. And it was a fintech startup, and it was the CTO who'd mailed them. And it was only a startup, so it was a fairly small stack. And even with that startup, he couldn't bring up his dev stack, even though he'd been given this, amazing brand new M1 laptop, and it had 64 gig of RAM. And when he started to try and bring up all of the containers, smoke was practically coming out of his laptop. So we did sort of go back and say, yeah, we can help you with this. And by the way, have you considered Quarkus? Because probably, Quarkus could actually bring up that stack. But that's not really the point. The point is you probably shouldn't have this kind of environment. And when you have all of these containers, then you often end up with all of this sort of tuning and maintenance and orchestration and the Docker Compose, and then the Docker Compose doesn't work, and then you have to do this manual tuning, and it's just really complicated. And I think there's another lesson here, which is just like TDD is a useful design tool, testing in general is a useful design tool. And so if in order to get confidence in one service, you have to bring up all of these other services, that's maybe telling you that you got your domain boundaries wrong, and there is too much traffic and too much connection between some of these services. But often, instead of redefining our boundaries, when we have this kind of environment that we cannot bring up locally, what we do is we go, it is the magic of the cloud. I will put it on a remote sandbox, and then I don't need to worry about my laptop. But this, of course, has its own problems. When in the Lyft engineering blog, they used to talk about how they had systems like this. And one of the problems they had was an enormous cloud bill cost, because they had all of these huge environments running. And there was the inner loop for the developers was really slow, because every time they wanted to make a change, they'd have to sort of push it to a remote cloud. And so I think definitely a better approach than that, if you can do it, is to keep the service under test on your own laptop and do what's called, it's called various things, so often it's called a remocal sandbox, which I quite like because it's sort of a cute word. Some telepresence is a useful tool for this. There's others. But the idea basically is that you have an environment that has all of the services in it. It's usually shared, but not necessarily. You develop your service on your laptop, but anytime it needs to send traffic to another service, that service is up on the cloud. And as well, it can accept traffic from the cloud, so that you can go to your web browser and interact with the system, and the right request will be routed to your laptop for the thing that you're changing. So that is a really cool developer experience. There are some downsides. One is it needs a lot of setup, so you probably need to invest time in it. The other thing is I always feel a little bit worried about this kind of system, because it relies on a lot of plumbing. It relies on every service forward, it relies on magic headers. And so every service has to forward the headers to the next one in the chain so that it knows when it should go out to your laptop. And it's very dependent on REST, because it is dependent on those magic HTTP headers. So if you're doing like Kafka or something, not so much. And as well, I always worry about if something misbehaves, then you have a potentially quite large blast radius in terms of corrupting the data or sending all of the traffic to the wrong place. So it's cool, but it's not perfect, particularly if you have that kind of shared environment where then you really do risk crosstalk. But because it's shared, it's cheaper. So instead, what a lot of times what we want to do is we want to say, like, this remocal environment, it's really cool, but then I can't do it on a plane. And I just really want to be able to develop just on my laptop and just not have to worry about the networks. I took the train here, obviously, but I mean, I took the Eurostar. And the Wi-Fi on the Eurostar is the most maddening thing, because it almost works. So if it was just a plane, I'd say, I have no Wi-Fi, this is okay. But the Wi-Fi on the Eurostar, it's like, oh yeah, I'll give you, a few packets. And then you spend the rest of the journey going refresh, 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 hoping you can get the other packets. And so I think sometimes it's better to just say, no, we're not gonna have a network dependency. We're just gonna have something that's a little bit more isolated. And so what we want to do is just have stuff work, but have it work on our machine and still give us the confidence. And this is where test containers can be really, really cool. So test containers gives you the convenience of a mock, but the realism of a real thing, which is about as cool as you can get. So let me do a quick little demo of test containers. So I have here, I'm just going to do a quick demo. So I've got, can we all see that? Yeah, more or less. I've got a little Quarkus application. And so what it's got is it's just got a really simple endpoint where I can call, get tracking, and it just reads how many tracking entities there are in the database. And the tracker entity just has one field, but really I just count them. So if I do Quarkus dev, then what will happen is I should get, yes, I get an error. So why do I get an error? Well, I've got Hibernate as one of my dependencies, but I don't actually have any JDBC driver at all, any JDBC support. So let me quit that and do, let me add in the JDBC Postgres. And so now if I start it again, it should work. And so you can see in here, it's not very visible. Right, so now if I go to, oops, if I go here, I can get, it's been called one time. I can keep refreshing. Sorry, let me make that 1,000,000 times bigger. So far, so boring, because I say I'm using Hibernate. I could just be doing it in memory. But what you can see, if we go back here, is if I bring up a new window, and if I do podman ps, you can see I've got Postgres started. And then if I stop my application, we should see that I still have Postgres started. If I, where's that come from? Nope, I still have Postgres started. Live demos just say no. So what you're supposed to see is that the Postgres instances get stopped. And what you can also see, actually, I think I know why we're seeing that. So I'm going to start another one on port 8086. So what's happening here is that Quarkus is saying, well, you're using JDBC Postgres. You don't have anything configured. You probably want a database. I'll just spin one up using test containers. And so then if I go to this, but on 8086, then we can see, again, you can see this could just be in memory, but if I flip back and forth, yeah. So they're getting their, each one's getting its own database. But if I stop that, and if I do this, and I'm going to tell test containers I'd quite like to reuse my containers. So now if I go back here, and if I start them again, Quarkus has a dev mode where it will do most things live, but something like your test containers configuration, it won't poll that, so you will need to restart it. And now what we should find is if I go here, I should get it called 1. So 8086 sees 1. And if I go to 8080, I should see 2. And if I go back to 8086, I should see 3, 4. And then if I go back here, I should see 5. So you can see I've got sort of for free a real database that's being able to be shared between my instances. And here I'm testing manually. But if I had tests, it would be the exact same thing. Quarkus would be saying, you must need a database. Let me just make one for you. So that's so convenient. Quarkus has quite a deep test containers integration. So if you're not using Quarkus, like here, I don't even have any line of code that says test containers. If you're not using Quarkus, it needs like a few lines of code, but it's still not much. And the other thing I can show is, again, that like, if I actually configured a database, then Quarkus would not spin one up because it knows I've got one. So here I've got a database that doesn't actually exist. And then if I go here, and if I refresh, I should get, I've got an error because I've told Quarkus, hey, don't use test containers, use a real database, but there is no real database. So that's sort of a quick view of test containers. And one of the things that test containers does, which is, so they've got images that you can use for most of the common things, or you can put your own container in. But one of the main things that test containers does is, that's a real value, is it kills your images for you. So there, because I've got reuse set to true, it won't automatically kill them. But otherwise, every time you quit, it just takes your image down. That's cool, but it still has some advantages, which is if I had a really complex application and I spun up zillions of test container databases, it still would be using CPU. A more significant drawback is that is awesome for something like a database. It's less awesome for Bob down the halls service because it's for well-known libraries. But again, like I said, it's so easy that it's definitely something that you want in your testing arsenal. It just won't solve everything. So another thing that you can do that's really useful is contract tests. So contract tests are for that other category that you can't do with test containers of services that you talk to. So going back to this example of why the mocks aren't enough, what contract tests do is they're kind of a middle layer in that communication. And so my code runs against a mock that is part of the contract test framework. For their code, the contract test framework provides a functional test. And so we're still, instead of communicating directly, which would be expensive and annoying and need orchestration, we're both just using the contract testing framework, and it's mediating that communication, and it's giving something to both sides. And so it means that it gives us a lot of confidence that if the tests are green, we're probably okay. And if they change something, their tests will break because reality is broken. And similarly, if I change how I use the service, my tests will break. So it's really quite useful. It's also a really nice fit with test-driven development and a nice design tool. So let me just quickly show a little bit of that. So this same application that I had here, I have the world's simplest microservices application because microservices are annoying and I didn't want to stand up 6. So I just have one. So I've got a front end and a back end. And so what we can see here, this is the front end running. If I just show the back end, you can see I've got the model was, whoops, where's that one? The model was someone who gets up and then they move through various rooms in the house. So each room in the house could be a microservice, except I did it all in one. And then all of the body parts are the data model. And so you can see how we understand the data model. And if I refresh, you can see that the various body parts sort of change. So the hair starts out kind of frizzled, and then it gets combed. And when we go to the kitchen, then the stomach was quite empty, and then it becomes full. So what could go wrong? Well, if I go to my backend, I've got this resident resource here. And I've got this object called a torso. And in my resident resource, I've got, I get the body. So let's go to my torso. And, sorry, let's go to my resident. And so here I've got everything. And torso's kind of one of those words that it's a bit of a fancy word. So let's change it to something simpler. So let's change it to get stomach. And then if I go here, then I should find, that's not so good. The UI, which is the other part of the system, has broken because in my data model, oops, here, it's a stomach. So what we can do, I'm just going to, and the thing is as well, like I had tests, all my unit tests are still passing. So on my front-end side, I have this resident table test. I'm just going to pull back from source control. In the last place I look. I'm going to pull back my contract test. And this looks a lot like a normal test. So I spend some time defining the mock and what the mock could look like. And then I've got some tests that are just testing the front end in exactly the same way as I would here. And so if I run that with npm run test, that will pass. And as well as passing, it will generate me a file which is, I do wish IntelliJ would refresh its files a bit more aggressively. So it will generate me a contract. And so if I copy that contract, let me just do it again. So I'm going to copy my contract. It will not generate me a contract. Let me run all my tests. And then it will very slowly run. And so the tests here are passing, even though the system is broken. Because from the consumer's point of view, it's just setting its expectations into the mock, and it's saying you should have something called torso. And so if I go back, and I now try and do that copy. So I do my copy. And then on this side, in my resources, I should have a Pact. So this is a JSON document that just describes what I expect my interactions to look like. So it's a bit like an open API schema, but it will hold a lot more information. And so now, Quarkus, normally it does like a reverse test coverage technique to work out what tests it should run. In this case, because it was just on the file system, it didn't. But if I rerun my tests, and if I add my provider test, so here, on the provider test, it's really small. All I'm saying is I'm going to tell Pact where to find my server, and then I'm going to use a JUnit template to say, Pact, do what's in that contract file, please verify it. So if I roll that back and bring that back in, then you can see all of a sudden my test is failing because I'm saying it should be torso and it's stomach. So let's go back to torso, to resident rather, and let's undo that. So here, let's do the refactor and do get torso. And now my tests are green. And if I go back to my UI, again, I should see that everything is green. So that kind of validation, it was the top level field name. So you can use something like Pact, but you could also just catch it with OpenAPI. But there's more subtle problems that OpenAPI wouldn't catch. So if, for example, I go to my hair, and I say, instead of being frizzled, my hair is going to be wild for its initial state. And then if I go here, if I run that, you can see, it's missing hair. Again, there was a miscommunication that didn't get updated until the hair got combed. And if I go back here, you can see, whoops, that was not the failure we were expecting. Oh, I think I did an incomplete refactor. But I won't worry about it. But you can take my word for it that once I fix that error, then you should see an error that says, hey, your hair was supposed to be frizzled and it's wild. So you can catch those kind of expectations problems as well. So basically, consumer-driven contract testing can be really, really useful. Having said that, a lot of teams don't use it. And I'm always trying to figure out, okay, well, why isn't it more popular? And I think it can be a bit hard to set up, and it can seem like duplication of other things. So it's worth getting it into your process early, because it can have a lot of benefits, particularly if you do consumer-driven contract testing. It helps you preserve backwards compatibility, and it also means that if you let your consumers give you the contract for what you're supposed to do, you can do YAGNI, which means you only need to code what's actually being used. And you can also do YAWIBNIC, which is you already wrote it, but now you can safely delete it. Because if you've got this API endpoint, Normally, you can't delete it because someone might be using it. But if you know no one's using it, you can get rid of it. So there's a few ways you can do contract testing. I personally like Pact. So to wrap up, I've kind of given a big view of kind of the strategy for microservices testing and what your options. But what does that mean for you? What should you actually do? Well, I would recommend, if you don't have a big platform team, a combination of test containers and contract testing is the way to go. If you do have a platform team, then you probably also want to bring in some kind of remote development, but also have the contract testing and the test containers. And then hopefully with that, then you do get to the point where you do actually have the confidence that the thing, which is the whole system, works. So test early, test often. Test containers is so cool. It's old news, but test containers is so cool. Contract testing can prevent so much pain. And even if you're doing microservices, you do have to think locally, but then also think at the system level. And with that, thank you very much. Enjoy the last talk. There's slides and code are there. Thank you.